Oh, Math 30-1. Stretches in X and Y, just digging a little bit deeper into stretching about X and Y axes. So please review the notation discussed here and think deeply about that and ask in class if there's anything that seems ambiguous, confusing, or anything about that, because they can ask these things in forward and backward ways, and we need to make sure that we don't just know it, but we actually understand it, all right? So check that over, that review, and make sure it's clear. As we look over, what I want you to notice is that what's different in lesson 6 is that here we're not just talking about a transformation or a replacement, we're actually looking at the equation of the real equation. So in the first one, what would y equals x squared look like with a horizontal stretch of 3/4? Well, we would simply plug in 3/4 into our function, and therefore we would get y equals, notice that because there was a horizontal stretch of 3/4, my replacement is 4/3 x. Therefore, y equals 4/3 x bracket squared, which equals y equals 16/9 x squared. And in the next one, again, let's look carefully. We have this as our function, right? And we are doing this to it. We are horizontally stretching by a factor of 4. And I like to underline as I do things just to make sure I'm not missing. And then I will vertically stretch by a factor of 2 about the x-axis. Okay, so my two replacements are, if I horizontally stretch by 4, then my b value is 1/4. And if I vertically stretch by 2, then I should have a 2 right beside the f. Or I would have a 1/2 over there. We just need to be careful how we write it. Therefore, my new equation would be a 2 out in front of bracket a square root of 1/4 x minus 3. And we'll just write that a little bit clearer. Square root of 1/4 x minus 3. And therefore, if you were to simplify this, we can do a little bit of work here. If you were to simplify this, now you're going to say, okay, well, this is really y equals 2. Square root of 1/4 is 1/2 square root x minus 3, which now becomes, oops, sorry, I actually forgot to multiply by 2, which now becomes 6, and that equals root x minus 6. So y equals root x minus 6 is our final equation for that transformation, for that image. In the last one, we have a line. Lines are kind of boring, but still we need to complete these at times. Vertical stretch about the x-axis by 1/3 and a reflection in the x-axis. So what's the transformation? Well, a negative on the outside will be the reflection, and a 1/3 is going to result in that vertical stretch. Therefore, I have y equals a minus 1/3 outside the whole function of 3x plus 7. What does that do to the function? I now get minus x minus 7/3. And we continue. As you ponder these transformations, describe how the graph of the second function compares to the first. So as you look at each sketch, as you look at each replacement, consider what that does to it. So in the first one, I can see that x was replaced with 1/2 x, so that's a horizontal stretch by a factor of 2. In the second one, I can see what was replaced was x was replaced with 3x. That results in a horizontal stretch by a factor of 1/3. In C, what happened there? In C, what was replaced? Well, in C, it seems that I have y is replaced with minus 1/2 y, minus 1/2 y. Therefore, there's two things that happen. There's a vertical stretch by 2, and there's also a reflection in the x-axis. D tricky little guys in D. D could be written as y equals 1/3 x squared. You just have to be careful with these notations. So really this is a y being replaced with 3y, and you have to make sure we see that as a vertical stretch of 1/3 instead of thinking that that's a vertical stretch of 3. When we look at E again, what was replaced? Well, there's two replacements there. X is being replaced with 1/3 x, and also y would be replaced with 1/2 y. There is a vertical stretch by 2 and a horizontal stretch by 3. And lastly, we can see that x is being replaced with 2x, but you also have x being replaced with the minus x. And I could have done it in one statement, but so that means there's a horizontal stretch of 1/2, but there's also a reflection in the y-axis as well. In the last example, they want us to consider the thick line as a stretch of the thin line and write an equation based on that. And some of them have actual equations, and some of them we'll just have to write as functions. Okay? They don't give us the exact equation. So in the first one, they actually give us an equation, but I'll write it as a transformation first. So what's going on there? Well, clearly in this graph there is a vertical stretch by 1/2 about the x-axis. So the vertical stretch by 1/2. How does that affect the actual graph? Well, that's going to be y equals 1/2 f at x. In question B, there's clearly a vertical stretch by 2, blah, 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 about the x-axis, and a reflection, right, in not just one axis, but a reflect in both x and y-axis. You have to reflect it in both. Therefore, when we look at this function, we end up with, and I need to correct that, we end up with minus 2 f at minus x. All right. Now, if we just go back to question A for a second, we actually have an equation there. Therefore, I can actually complete the transformation and make an equation that actually I can type in my calculator. So if I was to write this one, I could write this one as, therefore, y is equal to 1/2 times 6 over x squared plus 1. And we could simplify that a little bit and write this as y equals 3 over x squared plus 1. All right. For the second one, we can't really write anything for that because it doesn't have an actual equation for that picture. It's just a picture. And lastly, in C, we got this funky little polynomial graph that we'll talk about later. It does have an equation, but first off, what does it happen to it? Well, it has been horizontally stretched by a factor of, well, let's see, 1, 2, 3, 4, 1, 2, 3, 4. So it's been horizontally stretched by 2. Therefore, we would write that transformation equation, and if we replace x with 1/2 x, we now get a new function that looks like this, and our final answer would be, if we factor out all those 1/2s that are a pain, if we factor them all out, we end up with y is equal to 1/8 times x plus 8 times x minus 4 times x minus 12. It is now the final equation that we should be able to type in our calculator that would graph that. All right, that's lesson 6. And we are going to continue on in lesson 7 with putting all these things together.